Welcome back. In lesson number 3.5, we are looking at questions involving implicit differentiation, and here is another one where we will learn a few more tricks. You are given that y cubed is equal to x divided by into bracket xy plus y, and you're asked to find the first and the second derivative. How do we go about this particular problem? Right, so while it is possible to differentiate implicitly by differentiating the left-hand side and the right-hand side using quotient rule, in this particular question it's in fact best to get rid of the fraction by multiplying through by that denominator there, xy plus y. So if we do that, so by the way, that is how the graph of this function looks like. So first of all, we're going to just write this in a straight line, get rid of that fraction on the right hand side. Let's do that. So let's get rid of the fraction by cross multiplying or multiplying both sides by xy plus y. If we do that, we get that xy power 4 plus y power 4 equals x. So this is easier to differentiate than that. Of course, there will be times when that expression is easier to differentiate than this expression, but in this particular case, it's easier when you write it in one level like that. So then we make use of our problem, our method of differentiating by product rule for the first term there. We will have x d of y power 4 by dx. So keep this as a constant and differentiate that. And what do we get when we do that? So we do that and then we keep y power 4 constant and differentiate x. So let's see what we get. So if we differentiate, so we'll say x d of y power 4 plus y power 4 d of x. And then we'll say plus, we go to the second term there, we are going to differentiate y to the power of 4, and then we will equate to the derivative of x. Okay, that's easy to simplify now. If we simplify, what do we get here? We get x, and this becomes 4y power 3 dy by dx. Okay, so x times 4y power 3, and because we are differentiating with respect to a different variable, there has to be a residue remaining there, which is dy by dx. So we get, I'm writing the simplified form, so 4xy cubed dy by dx plus dx by dx is just 1, so plus 4y plus y power 4, and then we have to add the next one there is 4y cubed. When we differentiate that, 4y cubed dy by dx, and that must be equal to 1 on the right hand side. When we simplify that, we can simplify this if we want, but in fact, if we are interested in the second derivative, this would already be enough to proceed. So the first derivative then, that's the first derivative, which we can express as dy by dx by collecting like terms together. Dy by dx is given by that. Okay, so this is our first derivative. We're making dy by dx the subject of the formula. It is also fine to leave it in a straight line in one level like that. There would be no problem. That would be the first derivative. But to find the second derivative, it's better to have it in this form, in this case, than to leave it like this. So instead of using the quotient rule there, we can leave it like this and just work with the product rule there, and the other places will remain the same, right? So let's see how we do this. So that's the answer to part 1 of the question. So part 2 of the question then, we want to find the second derivative. The second derivative is the derivative of the first derivative. Okay, so keeping that in mind and working with the previous result, which was this, we want to differentiate this. So working with the previous result, which was this here, we are going to differentiate it the way it is. So using our product rule method again. Now we have 3 variables, so treat dy by dx here as a separate variable. So we have that there, x there, we have y cubed, and then we have dy by dx. That is a constant. Similarly, here we have y cubed and we have dy by dx. that is a constant. So to differentiate, this is going to be a product rule involving 3 variables. This is a product rule involving 2 variables. So to solve that, we will start by, we will keep 4 out, then have xy cubed as a constant and differentiate dy by dx. Next, we will keep x and dy dx constant and then differentiate y cubed. And lastly, we will keep y cubed dy dx constant and differentiate x there. And we'll do the same with the other side. So let's see how we go about this here. And so, keeping 4 outside, we have xy cubed kept as constant and we differentiate that. So differentiate dy by dx. That is, we are differentiating that. Then we say plus x dy by dx kept as constant. So we have x dy by dx kept constant, and now we differentiate y cubed. And if we differentiate y cubed, we get 3y squared dy by dx. Okay, so we've differentiated that term there, or that expression there. Next, we will keep y cubed dy dx constant and differentiate x there. So we will be differentiating the x there. What do we have? So we'll have y cubed dy by dx times the derivative of x. Okay, like that. Next, we will differentiate this. This is easier to do now. Okay, and that is just 4y cubed with a residue dy dx. So 4y cubed dy dx. And now we move to the next part. Put the 4 out, or keep the 4 out of the bracket, and differentiate this, keeping y cubed constant. So we keep y cubed constant and differentiate dy by dx. And then we say plus, now we keep dy by dx constant there, and we differentiate y cubed, which is going to give me 3y squared dy by dx, like that. All right, and that becomes 0 because the derivative of 1 there equals 0. Now we just need to simplify this. If we simplify that, that gives me 4x y cubed d squared y by dx squared. That's that first 4 times this. The next one is going to be 12 because 4 times 3. So 12xy squared dy by dx, everything squared, because there's a dy by dx here and dy by dx there, so we are squaring that. So we end up with dy by dx squared. Notice that this is different from that. Okay, next we have this term here, dx by dx. This is 1, so we are left with y cubed dy by dx times 4. So 4 y cubed dy by dx, but there is another 4y cubed dy by dx. So effectively we have 8y cubed dy by dx there. Now we are here, simplify this. We have 4y cubed d squared y by dx squared, right? And lastly, 4 multiplied by that is 12y squared dy by dx into bracket squared. Okay, like that. So if we combine this term and that term there, then we have 4xy cubed and 4y cubed. So 4y cubed is common. So I can say 4y cubed into x plus 1 d squared y by dx squared. And then I have this and that as also like terms. And again, I can see 12y squared being common. So I can write 12y squared into x plus 1 dy by dx squared. So like that, and this equals 0. There is one term still remaining here, this one here, 8y cubed dy by dx, okay? And so this equals 0, and this is our second derivative. Of course, we can choose to make d squared y by dx squared subject of the formula, but we don't really have to. Any question that we need to solve relating to the second derivative can be determined right here, but if you need to write it as in terms of d squared y by dx squared, you can do so. Also remember that dy by dx is something we had found earlier. I believe I have it written somewhere. There it is. This is what we found for dy by dx. So we could take that and replace wherever there is dy by dx, we can put that. But what that does is it just makes this more complicated. So it's better to actually leave it like this. And together with that, you can solve any question that anyone would want to ask you regarding a question like this. All right? Hope you understood this. If there is any issue, let me know, and we can go through it together. If you're liking these videos, please consider sharing it with other individuals who may also find it useful, and also consider liking our videos and subscribing to the channel so that when we produce any video, you will be able to be notified. All right, thank you. We'll look at the next question.